class, we have learned on semiconductor and diode, and basically we have covered on the fundamentals of semiconductor. This is just quick recap what we have learned in previous class. We have conductor and insulator. What is in conductor? Conductivity high. Okay, for insulator, conductivity is low or approximate to 0. Okay, and between these two, we have semiconductor. What other types semiconductor do we have normally? Silicon, germanium, gallium arsenide. But then normally kita use these two lah. Okay, for silicon, what are the built-in potential value? 0.7 voltage. For germanium, 0.3. Okay, and the semiconductor, dia ada how many types? What are they? Intrinsic and extrinsic. Okay, for intrinsic, what is that? Pure. No impurities. Okay, for extrinsic, what is that? Apa? Added dopant or the impurities. Okay, meaning that from intrinsic, dia tambah dopant, it will become the extrinsic. Through what process? Doping process. And then it will become N-type and P-type. For N-type, majority carrier is electron. P-type, majority carrier is hole. Okay, and then when we have two, this one is PN junction. From the PN junction, we can have the yang bawah ni apa? Diode. Diode ada dua jenis normally. Okay, so this is basically what we have learned in previous class lah. Ada lagi tak? Okay, ini yang previous class what we have learned. I want to show on this one, yang ni. Saya lukis mula kat bawah ni. We have VS. Ya? Apa? Ni? Ni kan? Okay. So we have, saya lukis semula. One diode, resistor. Okay, ground. This is VS, D, R1, R2. Sebenarnya for this circuit, dia boleh juga lukis macam ni. Sama je. Okay. And for the diode, please be careful on the polarity dia. Okay. For this closed loop, dia buat macam ni, KVL. For this one, dia turun ke bawah. Okay. Let's say I put note kat sini is VA. And VB kat mana? Okay, VB in here. Okay, let's do the KVL first. Macam mana nak buat KVL dia? Minus VS plus VD plus VR1 plus VR2 equals to 0. Okay, and then you can say minus VS plus VD plus IR1 plus IR2 equals to 0. IR1, this I is similar kan? Because it is one path. Okay, it carry the same value of current if it is in one path. Okay, meaning that current yang dekat atas ni dengan current dekat tengah ni ke, it is same value. Okay, alright. So can you give me ni, saya nak tahu voltage kat tengah ni. Let's say it is VD. What is VD? VD is equals to VA minus VB. Because VD is the voltage drop in between two node A and node B. Ataupun VD is actually the value of the diode. Okay, kalau saya tulis VA is equals to VS, betul tak? Because same node kat sini kan, dia tak ada apa-apa elemen in between. Okay, and what is VB pula? VB is from here to ground. VR1 plus VR2. Okay, apa lagi ada kat atas ni, sama je kan? Alright, so I want you guys untuk tahu baca from one node to one node for the voltage drop. Katakanlah dekat bawah ni dia bukan ground. Let's say dia ada ni tolak 5. So kalau VB, VR1 plus VR2 minus 5, baru dia sambung ke ground bawah ni. Sebab dia ada lagi satu voltage drop dekat bawah ni, which is dia jumpa dengan tolak 5. Sebab dia letak negatif kat atas. Kalau dia letak positif, and then you kena tambah. Okay, boleh tak? Contohnya kalau dekat dalam circuit ni, kat sini dia tambah lagi satu, and then here is dia letak negatif. Sebab dia jumpa negatif dulu. Tu yang kalau macam ni kita buat straight ke bawah, dia akan letak negatif dulu. Kalau negatif lah. Okay, kalau dia terbalik positif, dan kita letak positif. Boleh? Alright, so this one is what we have learned in previous class. Recap. For those who masih lagi tak berapa nampak how to do the KVL, please do some revision, because that one akan carry your knowledge untuk, especially for chapter 3. Okay, this one kita dah buat belum? Dah kan? Okay, as you guys can see, V out is dekat sini. So kalau kita lukis macam tadi, plus 12, dia ada one diode, another diode, dia goes to 5.6 ground. So V out dekat sini. Okay, meaning that V out is at this respective. Dapatkan the I, V out equals to I R2. Okay. Dia ada satu lagi. Okey, dia beza dengan yang ni. Okay, yang ni V out is at here, but then V2 is until this one je. Sebab dia letak ni positif, negatif for V2. So kalau V out from here to the ground, V2 only at this point. This is V out. Nampak tak? Yang ni dia pergi letak one voltage source dekat bawah. Okay. Okay, this is the solution dia. Ni V out is V2 minus the voltage source tu. Voltage source yang ni. Okay. Alright. For the silicon is 0.7 kan, built-in potential voltage dia. For germanium 0.3. Okay. Katakanlah the voltage source is, for here this one dia letak 10. Contohnya dia letak 0.5. Okay. The built-in potential is potential voltage source yang diperlukan to turn on the diode. Minimum. Okay. So it is actually, kalau you tengok notes yang sebelum ni, dia ada tulis yang macam ni. Okay. So voltage source must be greater than the built-in potential voltage dia. So kalau this one is both silicon, kalau voltage source is 0.5, so this diode cannot be on. Dia takkan function. The supply must be greater than built-in potential voltage. Must be greater than this value. Okay, kalau if for germanium, then it must be greater than 0.3. Or 0.3 lah. Greater or equal. Okay. Alright, for this circuit, this one, we have two silicon in parallel. So, it is either you can proceed with this circuit to solve, or you can convert into this battery or voltage source. Sama je. Nak lukis balik boleh, tak nak lukis pun tak apa. Okay, for this one, dia akan masuk kod sini. So, this one will turn on first. 0.7. Okay, actually dia bahagi dua ni. This ID, I equals to ID1 plus ID2. What is the value for I? Minus 10 plus 0.33 Ki plus 0.7 equals to 0. Tolong dapatkan value of the I. I equals to berapa? 0.023 238 ke 28 ampere. Ampere ke mili? Ampere. Okay, so for this one, since this built-in potential voltage untuk operate for these two diode is sama. Okay, 0.7 sebab dia pakai silicon, so dia akan on sama-sama. And the I okay, bukan dia bahagi dua, sorry betul lah, tapi equals to I1 bahagi 2. Okay, and this one V out is berapa value V out? Berapa? Kalau saya lukis macam ni, so V out is actually at this point, ataupun sama dengan value ni, equals to 0.7. Dia tak sama dengan E dia ambil dari atas, dia ada the resistor kat atas ni. E equals to VR plus ni SI VD ni, kan kita buat KVL tadi, minus E plus VR plus VD equals to 0. Okay, so E equals to voltage here plus voltage at this point, V out at this point sahaja. Okay, saya nak tunjuk what happen kalau in the circuit if we have silicon and germanium in one circuit. Okay, let's say this is germanium, this is silicon. Okay, R E. Germanium, what is the value? Voltage dia berapa? 0.3. Okay, this is not on 0.3. This is not on 0. So which one will turn on first? For this case, the current tak akan sama. So 0.3 will turn on dulu. Okay, contohnya dia nak on. Okay, dia akan inject voltage, current akan lalu. Tak sampai 0.3 dia pun nyala. LED ke contohnya, dia akan on dulu. This one, once dia dah on, all the I dia akan pergi sini. Sebab ini dah on, so yang ini tak nyala. When this one tak on, I will be, let's say this one I1, I2 will be 0. So V out dia adalah, bila ni tak ada, V out dia adalah 0.3. Ikut yang mana akan on tu. Okay, So I1 is equals to I total, because I2 is equals to 0. Dia sebenarnya I total equals to I1 plus I2, but then I2 is 0. Kalau yang tadi I total equals to I1 lah, I1 equals to ID1 plus ID2, because this one is 0.7. Dia akan on sampai 0.7. Both of this diode will turn on simultaneously at same time. Dia akan on sama-sama. So current dia tu sebagi kau pergi sana separuh masuk sini. Okay, because dia punya built-in potential value yang diperlukan untuk on sama. Okay, dia tak ada yang ini lagi hampir, yang sana jauh, kita tak payah pergi sana lah, kita pergi yang dekat. Dia tak ada. For the current kan, dia boleh dia punya movement dia kan laju arus. Okay, tetapi dia akan tengok kepada potential dia, voltage potential dia, voltage drop dia. For this one, okay, sampai 0.3 terus on. Datang sini semua. Yang ini dah nyala dah buka pintu. Tak perlu nak tunggu 0.7. Bila dia dah on, terus lalu sini dah. Okay, same goes kalau sini tak kira lah SI dulu ke GI dulu ke. Okay, once dia dah off, current tak ada, voltage akan ambil this V up. Okay, so only one circuit, one path je, one loop je. Dah ada loop tak ada. Alright. Okay, so this is actually LED. Sebab tu dia ada color. Okay, and diode kan kita apply dalam LED. LED dalam mentol pun ada. Okay, alright. So for this one, normally for the LED dia ada value dia, value voltage dia, respective value. Okay, as you guys can see here, for green is 2.2. Which one yang akan on ni? 2.2 voltage. Red is 1.8. Okay, tetapi this one is positive, negative, negative, positive. So which one will turn on? Which one? Why green? Sebab this one is open circuit, sebab dia negatif kan. Dia reverse bias off. Memanglah dia bagi voltage dia tu, tapi sebabkan dia off. Let's say bentuk dia macam ni. Kalau macam tu, which one? Red. So yang ini tak nyala. Okay, ini yang tadi open circuit, because reverse bias, dia terbalik polarity. Okay, this one okay, for this 0.7, this is 0.3. So yang ini which one yang akan turn on? Dia akan lalu which path? Now we have two paths kalau tengok sini. One, another one. So yang merah. Okay, so get me the I. KVL minus 12. Kenapa saya selalu buat minus 12? Sebab this one we consider as connect to this one. So plus negative, macam dia ada voltage source. So bila kita buat loop, kita akan masuk kod negatif dia. Okay. Minus 12 plus 0.3 plus I 2.2 K equals to 0. V out equals to ni I 2.2 K. So get me the value of I, then get me the value of V out. Berapa? 5.3? Ah? 5.32. I 5.32 milliampere. And then V out you darab lah. Okay? Okay, next one is we have two loops. What happens when we have two loops? This one is for the first loop. I want in here. I2 is here. This is I1 lah. Ataupun we can also draw sama kan? Ni D2, ni D1. Okay. So D2, what is the voltage dekat sini? 0.7. Sini 0.7 kan? Meaning that kat sini is 0.7 atas ke bawah. So we can easily get I. Kan? Sebab dia ada 0.7 tu dari atas ni sampai sini. Voltage. So the I is I1. Voltage tu ni 0.7 divide by the resistor. Ni kan same node. Bila same node, value of voltage dia samalah. Nampak tak? Sini. Ni sebab dia lukis sini. Bayangkan dia lukis kat sini. Tu yang saya letak ujung tu. Nampak tak? Where is the attendance? Semua dah sign ke? Jangan lupa nak sign lagi. Tak menjawab ni saya nak kena panggil nama. Afikah mana? Nampak tak? What is value for I? I dapat berapa? I1. I1. Berapa? Apa? 2.12 Ah? 10 negatif 4. Maksudnya apa tu? .2 milliampere. Sebab 2.12 10 negatif 4. Kita nak jadikan 10 negatif 3. Jadi dia akan jadi 0.3. Kita tarik sebelah dia punya titik perpuluhan. Okay, so that will be the I1 yang dekat sini. Sebab kita dah tahu dia punya voltage dekat situ, so we can easily get the I1. I equals to V over R. Okay, so now we want to get the I2. Kalau saya cakap kat sini I2, betul tak? I2 dia bagi dekat bawah ni. Kalau saya kata I2 dekat atas tu. Okay. Alright. So to get I2, we can do KVL. Okay. Minus 20 plus berapa? 0.7 plus 0.7 plus 5.6 KI2 equals to 0. So, can you get the I2? Boleh dapat tak? Okay, so get me value for I2. Berapa? 2 point? 5 point? Semula berapa? 5.17. Okay, 5.17 mili ke? Milliampere. Okay, 5.17 milliampere. Betul ke? Kat mana salah tu? 5.17 kat mana salah? Please check. Okay, so that one is I2. I1 dekat sini. We have another I is this one. Ni ID2. Okay, ID2 macam mana? Kalau tengok dia punya current flow dia, laluan current, dia punya KCL. I2 equals to ID2 plus I1. So ID2 equals to I2 minus I1. Boleh dapat tak? Tolak je kan? Yang ni tolak dengan this one. Okay. So you get this value. Inilah. Ni solution dia. Sama je, lebih kurang macam kita buat tadi. Okay. For this one, saya tak nak buat. Saya nak suruh you guys buat and submit to me next class. Okay. Sebab dah habis sejam, kita belum masuk lagi chapter 2. Okay, this one. Alright. Tulis tangan je, tak perlu nak type elok-elok. Okay, tulis tangan simple-simple je. Submit to me next class. Alright. So kita dah habis for 2A punya notes. Now we will go for 2B. For chapter 2 kita tak boleh nak bersenang-lenang seperti chapter 1, because chapter 2 we have 4 sets of notes. 2A, 2B. 2A is semiconductor and diode. 2B is for half wave rectifier, full wave rectifier. And 2C is for power supply. 2D for Zener diode. As I mentioned in previous class, for the calculation, please focus on 2A and 2D. Yang lain ni ada calculation dia, but then it is more on your fundamentals understanding. Okay. Alright, so what is rectifier? Pernah dengar rectifier? Semalam saya punya kelas semiconductor. Pernah dengar semiconductor? Kilang semiconductor. Sebut semiconductor, kilang juga yang dia terbayang kan. Jadi tak apalah. Nampaklah juga ada kilang tu. Okay, so this rectifier is actually, apa saya tulis? Rectify is to set right, ataupun we want to put something in a correct value lah. Okay. And rectifier is actually we use to convert the AC signal into DC signal. Okay. AC signal dia macam ni kan. Okay. We have positive and negative cycle. Whereas for DC signal is only one value. Normally dia akan ambil maximum peak ni. So dia akan convert to that. That one is done by the rectifier circuit. Why? Because as you guys know that from the plug point yang kita guna, that one is AC signal 240. Tapi when you want to charge your laptop, you want to charge your handphone, what are the value? Kalau tengok dekat charger kepala point tu berapa? Voltage dia berapa? 15 laptop kan. Kalau handphone saya rasa 5 je kot kan. Watt tu power dia, samalah kan. P equals to IV, dia boleh dapat juga. Kalau handphone charger saya rasa 5 kot, ke 12 juga. 20. Okay. Tapi dia bukan 240 kan. And it is actually DC value. Kalau you guys tengok pun kadang-kadang dia ada tulis DC. So, dekat dalam benda tu, it is actually ada rectifier punya circuit. Kita tak ambil straight away 240 tu kan. Kalau shock tiba-tiba you pula kepala dah cacak-cacak, ada arwah kat situ. And it is also not kalau macam handphone kita, kalau kita bagi 240 kan meletup pula handphone kita. Terbakar dah IC-IC semua yang kat dalam ni. Okay, so rectifier dengan voltage regulator circuit, dia punya tugas is to step down the value of the original signal, original sources kita 240 yang kita dapat daripada TMB punya line tu, and to cater with the requirement power yang kita perlukan. Dia tak perlukan power yang 240 pun untuk turn on, untuk operate. Okay, to charge dia punya battery. Just enough untuk operation. Kalau laptop dia tinggi sikit, kalau handphone dia rendah sikit. Okay, so have you come across when you charge tapi your charger tu rosak? Okay, and kalau macam tu something is wrong dekat dalam the circuit. Maybe dia punya diode dah terbakar. Okay, so dia tak boleh nak aruskan lah, and then dia terus pergi ground. There is certain situations di mana bila lightning, ada kilat, lepas tu bukan plug point yang terbakar, rice cooker ke yang meletup kan. Kalau macam tu dia punya grounding dekat circuit dia tu problem, so dia akan tetap aruskan elektrik juga. Kadang-kadang TV dia akan effect kan. So sebenarnya itu adalah kind of protection circuit. Tapi kalau protection circuit tu problem, so dia akan terus rosakkan devices kita. Okay. And pentingnya protection circuit tu supaya dia boleh terus cut off. Dia terus open circuit kan all the connection. So dia terus tak sampai tak mengalirkan arus yang besar kepada device kita. Kalau tak, device yang rosak kan. So instead of plug point yang rosak, so plug point boleh je senang nak baiki. Kalau device rosak biasanya dah tak boleh dah. Okay, depends lah, ada juga yang boleh baiki. Okay, so this one if you want to relate everyday use, hari-hari kita guna charger. And dekat dalam charger tu mesti ada, kalau ada dia punya diode lah, diode tu yang akan cover untuk forward bias. Kalau reverse bias dia tak boleh, dia terus off, rosak. Kalau dekat dalam mentol, pernah dengar yang mentol terbakar, fuse terbakar, so diode dia jugalah. So instead, kadang-kadang bila fuse tu terbakar, mentol tu okey, dia tak terbakar kan, fuse dia dulu yang terbakar. So kita just tukar the fuse. Fuse tu dia diode lah. Ataupun kalau mentol yang terbakar, dan kita kena tukar the mentol. Okay. Alright. So now we want to go for the rectifier. There ada two types of rectifier, half wave dengan full wave. Tengok sikit apa saya tulis. Rectifier is part of power supply circuit used as power distribution because we want to convert from AC signal yang ada positive and negative cycle into one line signal sahaja yang lagi stable. Okay, for the AC voltage or current, it is considered as bukanlah tak stable, tapi bila kita nak kira ataupun nak do analysis, it is lagi susah because dia continuous signal, dia ada phase, dia ada frequency dia. Okay, for AC it is more stable. AC dia straight je, dia ada amplitude sahaja. Sebab tu dia punya yang ni dia ada maximum peak dengan minimum peak. Apa benda pula Madam cakap tu? Okay, maximum peak yang dekat sini VP. Ini pun VP. So VPP ni apa? 2 VP. Sebab VP 1 dekat atas, another VP dekat bawah. So kalau dalam formula ke apa-apa dia just tulis VP, maksudnya you ambil on one cycle saja. Tak perlu ambil polarity dia, positive or negative. If it is tulis VPP, maksudnya voltage from peak to peak, from positive to negative peak. Okay. Whereas for AC signal kita cuma ada satu sahaja. Kita ada satu peak je. Dia macam ni lah sebenarnya. Dia akan jadi gini. Yang ni positive cycle. Nanti kita akan tengok in the circuit. This one is negative cycle. Yang belah bawah tadi dia naikkan belah atas. That is function of this rectifier. Why? Because we want to get the DC signal lah. From signal yang macam ni nak jadikan one straight line. Okay. And the rectifier sensing of amplitude for modulated radio signals. Normally kita banyak guna in radio signals. Okay, kita tengok on the circuit. Applications of diode is in the design of rectifier circuit. Meaning that in the rectifier circuit mesti kena ada diode. Okay, this is the PN junction as switch. Just nak tunjukkan we have cathode, anode and cathode. Okay, this one is closed circuit, open circuit. Or this one is reverse bias. I is equals to 0. Okay. Alright, so this one is for half wave rectifier. As you guys can see here, yang belah atas ni sine wave is the AC signal. Okay, the AC voltage AC lah. AC ke DC, signal ke voltage ataupun source current. Okay, dia adalah simultaneous sine wave. Okay, for half wave rectifier, it only conduct for positive cycle ataupun negative cycle, only one cycle. Kalau for this one dia tunjuk for positive. Dia cuma ambil yang positif atas ni je. Okay. Ataupun kalau kita tukar the circuit polarity tu, dia akan ambil yang negative cycle sahaja. Dia tak akan ambil both. Only one cycle for half wave rectifier. Kita tengok on the circuit. This is the circuit for half wave rectifier. Input is sinusoidal waveform, sine wave ataupun square wave boleh jugalah. Okay. So this is simple circuit. Mana saya tahu? Okay. So this is half wave rectifier circuit, contain one diode only. So since this is forward bias, so consider as short circuit. So it is on lah. Okay. And it only rectify, dia cuma ambil on positive cycle sahaja. Kalau nak ambil on negative cycle, dia kena tukar polarity, kena tukar diode punya ni. Tukar macam tu, dia akan jadi negative cycle. This diode only conduct when it is in forward bias. Diode turn on and conduct for positive signal cycle for period of half of the cycle ni. So kalau this one is 360 degree ataupun T, this one yang half is 160 for one cycle, 180, or T equal T over 2. Okay, from period 0 to T over 2 if it is for positive cycle. If kita tukar the polarity of VI, tukar polarity of the diode, that akan jadi for negative cycle. Okay, for negative cycle from T over 2 until T. Okay, and this type of circuit in which a single rectifier diode is applied with a time varying sinusoidal AC signal input to generate a DC output having a value half of the input is called the half wave rectifier. Okay, this one yang terbalik tadi tu. Okay. Oh, bukan. Just nak bagi tahu on the second yang ini dia tak lalu. Sebab open circuit. Okay. And this is formula to get on the VDC. Remember, kita nak dapatkan DC voltage. Okay. VDC 0.318. Mana nak datang 0.318? It is actually equals to Vmax over pi ataupun 1 over 5 Vm. Vmax tu Vm lah. 1 over 5 dapat berapa? Can you please 1 over 5 tu berapa? 1 over pi. So dia datang daripada 1 over 5 tu. Okay. Kenapa kita ambil kira pi? Because this one is sine voltage kan. Okay, Vm is V peak lah, maximum value of 1 peak tu. Ni. Okay, so this one is from the signal AC. Basically kita akan dapat macam ni, putus-putus for half wave rectifier. Okay, half wave rectification is a process in which one half of the cycle and eliminated by the diode at its output. So dia akan eliminate for another cycle. This one yang takkan kira. Okay. Yang ni tak ada apa. Yang VT ni boleh just ignore. Okay, since for this formula, kita just darab dengan Vm dia lah. From the original value. Original signal. So that will be the voltage DC yang kita dapat. So yang output kita tu akan jadi kalau negatif dan belah bawah lah. So this will be 6.36. Okay, from minus 20 of the sine wave, kita hanya akan dapat 6.36 watt sahaja voltage. Okay, because of this 1 over 5. We need to consider on the sinusoidal kan dia ada phase. Sebab tu kita ambil 1 over pi tu. Okay. Alright. Ni tak ada apa. Okay. So now I want to show on the full wave pula. Nak tengok yang full wave rectifier. We have two types of circuit. Bridge network and center tap transformer. Okay, for this full wave can convert high AC to low DC power, low DC voltage. Okay, circuit that rectifies the entire cycle. Kalau just now kita rectify only one cycle sahaja. For full wave, for both cycle. Okay. It can also, tapi kalau tadi kita only use one diode. So now dia guna 2 diode ataupun 4 diode. Depends on 2 types of circuit yang kita ada ni. Bridge dengan center tap. Okay. Alright. So this one lah. Since we akan rectify for both cycle, so dia akan jadi dua-dua naik atas. Yang ini naik atas ni. This one negative cycle, dia akan rectify jadi one cycle saja. Okay. Okay. This one is for full wave bridge rectifier network. Kalau tadi VDC dia 0. Kalau half wave 318 VM. How to get 636? Dia basically darab 2 kan? Sebab dia guna 2 diode. Okay. So dia ada 2 path. Since we have 2 diode, there will be 2 path. Satu dia akan pergi sini, lalu sini, go here, goes here to this one. Okay. So yang ini akan off dulu. This one will be off. This one. Goes here. Because kita take into consideration polarity of the diode kan. Okay. Yang ni dia tunjuk for both cycle. Okay, so yang ni dia lalu situ, pusing sini. For negative cycle, kita tukar polarity of the voltage source. Jadi macam ni. Kan, bila kita tukar the polarity this one, negative, negative and positive, dia akan pergi sini. Nak lalu mana ni? Lalu ni. Then goes here, keluar kot sini. Nampak tak? Dia tukar kan? Tapi dia still lalu kot resistor yang tengah tu. So this one lah. Dia lalu yang ni, pergi diode ni, goes here, goes the second diode and then out. So for the first positive half cycle, dia akan ambil yang cycle atas. For the second one, dia ambil yang cycle bawah. So dia akan jadi rectify naik atas lah. Okay. So this one VM minus 2 VD. So it is 0.636 sebab dia 2 kali lalu kot diode. 2 VD ni because 2 diode. Dia lalu the first diode and then the second diode. At one operation. Sekali lalu je terus lalu untuk 2 diodes. Okay. This one is one sample of calculations. I'm just going to skip for this one. Okay. I want to go for this full wave center tap transformer. The first circuit tadi bridge kan? Yang second one is center tap transformer. Okay, for this center tap transformer, we cater for both positive and negative cycle juga. This one is for positive cycle. This is for negative cycle. Okay, yang ini this one for this. Tapi for this center tap transformer, kita cuma hanya pakai one diode. Sebab kita change the polarity dekat transformer ni. Inilah dia punya explanation dia. Positive cycle VI applied to the primary of the transformer, the network will appear. Dia macam ni, dia lalu yang this one. And then ini akan open circuit dulu. Okay, for this first cycle. And then once dia close yang ni, dia akan cater for positive cycle. Nanti bila yang ni pula open, dia akan cater for this cycle pula. Like this one. Okay, this one open circuit, short circuit for here, and get for negative cycle, the second negative cycle. After rectified, sebelum rectify dia duduk bawah, after rectified dia akan jadi atas. Okay, ni lah sebelum rectified, this one is after rectified. Okay, I want to show the comparison between the two half wave dengan full wave. Okay, this one is waveform. Maximum peak dia is 100 equals to Vm lah kalau macam ni. Okay, but then please remember for the transformer dia ada primary dengan secondary punya ni. So kalau katakanlah VI dia dekat sini is, contohnya kalau VI is 100, kalau ratio dia 2:1, yang belah sini is 50. So Vm dia akan jadi 50. Mengurut dah dekat situ. Okay, for this one 0.5 darab dengan 100, so dapat half. Lepas tu bila half, sebenarnya the half 50 tu adalah V peak to peak. Okay, V peak to peak. Sebab it is transformer, so dia akan tricky dekat part transformer ni. So because it is V peak to peak, so for one VP is only 25. Okay, yang ni 24.3 ni sebab dia dah tolak dengan diode punya tu bila dia kira minus VD tu. Okay. Alright, so this is comparison. Comparison between half wave, bridge and center tap transformer. This two is full wave. Okay, 0.318 comes from, datang dari mana? 1/5. Vm is value V peak tu. Minus Vd, because in the circuit we have diode kan. So minus lah the diode tu. If VD in the circuit VD is germanium, so 0.3. Okay. For bridge rectifier, it use 2 diodes. Okay, for full wave. So kalau full wave, kita ambil double from the half wave. Okay, same goes for this one, center tap transformer, double from the half wave juga. Okay, and for here, why minus 2 VD untuk bridge? Because 2 diodes in one circuit, satu pass dia. Okay, for transformer, hanya ada 1 diode je in the circuit. Okay, itu beza dia. Okay, this one last one, sikit je lagi ni. Ni tak ada apa pun actually. The peak inverse voltage is the maximum voltage at the rectifier need to block at a given circuit. Okay, because for the diode, it only can cater for positive value for apa tu, forward bias. For forward bias. For reverse bias, kita kena guna Zener diode. Okay, to cater on the reverse region. In semiconductor diode, peak reverse voltage or peak inverse voltage is the maximum voltage that diode can withstand in the reverse direction without breaking down. Yang ini we will cover in Zener diode. Okay, for Zener diode kita guna sebab kita nak cover for the reverse bias. Kenapa? Because for certain situation kita perlukan reverse bias operation. Okay, tetapi dia sampai a limit sahaja baru the diode tu boleh function. Kalau exceed the limit, diode akan breakdown. Dia akan rosak juga. You biasa dengar lah, fuse terbakar lah. Itu bahasa pasar dia. Lepas ni sebut ni, reverse breakdown. Due to the avalanche. Due to the avalanche breakdown. Wow, apa tu? Kan? Saya dah belajar lah. Okay, dia sebenarnya yang you biasa dengar, lama fuse dah terbakar, so dia tak boleh function. Because dia dah exceed certain limit. Contohnya dia sampai 5 volt, 5 voltage je dia boleh lalu. Yang dekat bahagian reverse. Negatif 5 je. Reverse bias. Dan negatif 5.5 terus terbakar. Diode tu dah rosak. Why the diode tu senang sangat rosak madam? Alah, benda tu kecil je. Murah berapa ringgit je. Kan? So sebab tu lah dia senang je rosak. Then easily can be replaced lah. Okay. Ni tak ada apa. This one is just some exposure lah. So that nanti kita akan belajar on the inverse voltage dekat dalam Zener diode. Okay. Is there any question from you guys? Ada soalan tak? Tak ada. I will